Morning to everybody. So today we'll start the discussion on the subject mechanics of materials. And this subject is also called as strength of materials. To begin with the discussion on this subject, let's start discussing about the stress, strain and all the basic definitions related to this subject. So initially let's discuss about stress. What is the stress? It is the ratio of the external forces to the cross-section area of the material. Say for example, there is a material, okay, say for example it's a wire and a pendulum is hanging over here, and the ratio of external forces, what are the external forces acting on it? Okay, this force and the weight of this bob and also the cross section area. So what does the stress state? Stress is equal to ratio of external forces, that is F, divided by cross sectional area. So this is the basic information about stress. Okay, and what is strain? Strain is nothing but the ratio of change in length to the original length. That means epsilon is equal to delta L upon L. Okay. In case of deformations, the deformations perpendicular to the cross section is called as normal strain. The deformations parallel to the cross section is called as shear strain. You have to remember the definitions of this particular strains. Okay. Discussing about stress and strain, here comes the third one, that is Hooke's law. What is the statement given by Hooke's? Okay, strain of the material is directly proportional to the applied stress, okay, within the elastic limit of the material. Say for example, there is some certain elastic limit of the material beyond which the deformations cannot take place. So within that limit itself, the strain of the material has to be applied and it is directly proportional to the applied stress, which means Hooke's law states that stress is directly proportional to strain, okay, within the elastic limit, okay, which means E is the, okay, proportionality constant and epsilon is the strain. So sigma is equal to E into epsilon is the expression of Hooke's law. Okay, so this is what is the Hooke's law. Coming to the last one, that is Poisson's ratio. What is a Poisson's ratio here? Poisson's ratio is represented as mu. Okay, it is the ratio of the lateral strain to the longitudinal strain. So these are the basic definitions. Discussing about the stress strain diagram for the structural steel and for non-structural steel, that is non-ferrous materials. So we have the diagrammatic representation of the graph. So as you all know, stress is in terms of Newton per meter square. The SI unit of stress is Newton per meter square, which is also called as pascals. Okay, strain doesn't have any unit. Okay, you can see this particular diagram, it is the stress strain diagram for the structural steel, wherein initially from this point there is the linear increment. Okay, the stress is directly proportional to strain. So here there is obeying of Hooke's law, stress is directly proportional to strain here. Later this zone is called as plastic zone, where there is a slight reduction and there is the strain hardening going to take place here, which can also be called as okay, plastic plus strain hardening. That means initially there is a mild decrease and again there is a maximum increase. Okay, after a certain point what happens, the necking of the, okay, material takes place, wherein there is the normal reduction, and at certain point what happens, the material breaks. Okay, that point is called as breaking point or a fracture point. Okay, initially when there is increment of the stress and strain, that means when stress is directly proportional to strain, that time we get a slope. Okay, vertical one is called as y and the horizontal one is called as x. Okay, y divided by x gives us the slope, that is the slope is nothing but Young's modulus. Young's modulus is nothing but y by x. Now coming to the non-ferrous materials, you can see in this picture, so as usual, even there is a increment, that is there is obeying of Hooke's law and there is a formation of slope. Okay, Young's modulus is equal to y by x. Okay, same, there is increment up to this point, and at this particular point there is breaking, and at this particular point where the breaking point takes place, at that point the strength is called as breaking strength, or it is also called as rupture strength. So this is what we have discussed about the stress strain diagram for the structural steel and for the non-ferrous materials. Now discussing about the next important thing, that is principle of superposition. What does it state? For all the linear system, the net response caused by two or more stimuli is the sum of the responses that would have been caused by each of the stimulus. Say for example, this is a composite bar or any kind of bar that you are taking place that is present over here. Okay, initially the force acting for this particular bar is P1 and for this is P2. Okay, so P2 is going to take place, P1 is going to take place in this direction and P2 in this direction, and the net force is P1 plus P2, right? So this length is L by 2, this is L by 2, the area of this particular material is A, and the Young's modulus is E. Okay, similarly if you take this part one by one, so this is the part 1 and this is the part 2. Okay, here the P1 is going to take place in this direction and this distance is L by 2, and here for this P2 is taking in this direction, and the deformation caused here is delta L2. Here the deformation which is going to be caused is delta L1. So the delta L1 plus delta L2. So, okay, this is the net deformation. Delta L is equal to delta L1 plus delta L2. Now we'll discuss about the derivation of the equation delta L is equal to PL by AE, okay, which is also called as elongation of a bar. Say for example, this is a bar. Okay, the deformation that has taken place for this is delta L. Okay, this is L and this is P, and A is area of cross section, E is the Young's modulus. Okay, for this particular bar we have to derive the expression delta L is equal to PL by A. From Hooke's law, friends, from Hooke's law, what we have, stress is directly proportional to strain. Okay, with this we have Young's modulus E and strain. Okay, so E is equal to sigma upon epsilon is what we got. So this is our first equation, and we already know what is stress. Stress is force per unit cross sectional area, and we also know strain is nothing but change in length to the original length. Okay, delta L can be also written like this, or it can also be written as delta L upon L, like this also. So putting these equations, okay, this is equation 2, this is equation 3. Putting 2 and 3 in 1, what we have, E is equal to, what is sigma here, P by A, and what is epsilon here, delta L by L. So this implies E is equal to PL divided by A into delta L. Delta L can also if you substitute, if you put delta L in this position, E will come in the downward direction. So delta L is equal to PL divided by AE. So this is a simple derivation for the elongation of a bar. Now let us solve this problem. What they have asked, a compound bar has a tensile load of 35 kilonewton, okay, and determine the stress in each material and the load carried by each material and the extension of the bar. First they have asked us to find out sigma ST and sigma BR, and secondly they have asked us to find out what load carried, that is PST and PBR, and thirdly they have asked us to calculate the extension of the bar, that is delta L. So initially what they have given, ES and EBR, we have to convert it into Newton per meter square. They have given it in terms of gigapascal, that is ES is equal to 210 into 10 raised to plus 9 divided by 10 raised to 6, which gives 210 into 10 raised to 3 Newton per m square. EBR is equal to 95 into 10 raised to 9 divided by 10 raised to 6, which gives 95 into 10 raised to 6 Newton per mm square. Area of steel, that is how much? Steel is having the diameter of 25 mm square. So that is pi by 4 into 25 square, which happens to be how much? 490.87 mm square. Now for the brass, ABR is equal to pi by 4 into, what is this? This square minus this square. That means 35 square minus 25 square. If 471.24 mm square. The ratio same, so that is sigma steel by E steel is equal to sigma brass by E brass. Sigma steel divided by sigma brass is equal to E steel divided by E brass, which means what is E steel? 210 into 10 raised to 3 Newton per mm square divided by 95 into 10 raised to 3 Newton per mm square. So if we calculate this, what is the ratio you are going to get? Ratio is 2.21. Sigma ST divided by sigma brass is equal to 2.21. So sigma brass, I'll take it this side. So this becomes sigma ST is equal to 2.21 sigma brass. P is equal to summation of sigma into A, which means stress of steel into area of steel plus stress of brass into area of brass. 0.21 sigma BR into area of steel was 490.87, sigma brass as it is plus 35 into 10 raised to 3, 22.5 per mm square. Sigma S is equal to 2.21 sigma B. We already got sigma B as something 22.5. 2.21 into 22.5. This happens to be how much? 49.725 Newton per mm square. Now we'll calculate load on each member. So that is PS is equal to sigma into A. So sigma ST was how much? 49.725 into area was 490.87. Our answer was how much? 24.4 kilonewton. Now similarly, P brass is equal to sigma brass plus into area of brass. What was sigma brass? 22.5 into 471.24. Answer becomes 10.6 kilonewton. Delta L is equal to delta L of steel is equal to delta L of brass. Now delta L into S is equal to sigma S into LS upon ES. Okay. So what is sigma S? Sigma S is nothing but 49.725. Length of steel is 750 divided by E of steel is how much? 210 into 10 raised to 3. So if we calculate this, answer happens to be 0.17 mm. So delta L is 0.17 mm. Hope you have got this. Axial load of 100 kilonewton. It is acting on the both the ends. Okay, it is a stepped bar. We have to calculate the stress at each step. Okay, and we have to also calculate the elongation. Load is equal to 100 kilonewton, which means 100 into 10 power 3. E is equal to 2 into 10 raised to 5 Newton per mm square. 50 mm. So area of 1, that is pi by 4 into 50 square, which gives how much? 1963.5 mm square. Now stress is equal to P by A. So what is P here? 100 into 10 power 3 divided by, what is area here? 1963.5. So my answer for this is 50.93 Newton per mm square. Now delta L is equal to sigma L by E. So what is sigma here? 50.93 into 120 divided by E. E is 2 into 10 raised to 5. So if we calculate this, how much is your answer? 0.035305 mm. A2 is equal to, what is the die here? 30 mm. So pi by 4 into 30 square. So if you do this, how much you are going to get? It is 706.86 mm square. Now similarly we have to calculate sigma 2. Sigma 2 is equal to P2 by A2. What is P2 here? Same 100 kilonewton, 100 into 10 power 3 divided by A2 is how much? We have already got it, 706.86. So if we calculate this, sigma 2 is equal to 141.47 Newton per mm square. Delta L2 is equal to sigma 2 L2 by E2. What is sigma 2? 141.47 into L2 is 100 divided by E2 is 2 into 10 power 5. So what is delta L2? Delta L2 is how much? It is 0.07 mm. A3 is equal to, dia is 40, so pi by 4, 40 square. So if you do this, how much you are going to get? It is 1256.64 mm square. This is A3. Now similarly we have to find out sigma 3. Sigma 3 is equal to P3 by A3. What is P3 here? 100 into 10 power 3 divided by A3 is, we have calculated as 1256.64. So if we calculate this, sigma 3.58 Newton per mm square. Sigma 3 L3 upon E3. Sigma 3 is 79.58 into, what is L3? L3 is 80 divided by E3 is how much? 2 into 10 power 5. So if we calculate this, delta L3 is how much? You are going to get it as 0.0318 mm. So what is delta L? Delta L is equal to delta L1 plus delta L2 plus delta L3, which is 0.035305 plus 0.0707 plus 0.0319. So if you do this, how much you are going to get? Delta L is equal to 0.133 mm. If the maximum stress induced by the material is 50 Newton per mm square, elongation, that is modulus of Young's, that is Young's modulus is 1.03 to 10 raised to 5 Newton per mm square. What is the load and what is the change in length? Okay, that we have to find out, or else this is also called as elongation. Now let us write down the given quantities. The maximum stress induced is 50 Newton per mm square, and Young's modulus is 1.03 into 10 raised to 5 Newton per mm square is induced at smaller section. So it is very important to know. You have to remember section 2. We have sigma 2 is equal to P2 by A2. This implies P2 is equal to sigma 2 into A2. Sigma max into A2. 50 into area of second section is pi by 4 into 20 square. So if we calculate this, how much you are going to get? You are going to get 15.708 kilonewton. Is equal to delta L is equal to PL by AE plus PL by AE. So this is for first one. So that is P is the same and E is the same. Only L and A will vary. Okay. So if you take P and E as a common, P by E, L1 by A1 plus L2 by A2. So we have P is how much? 15708 Newton divided by E is how much? E is 1.03 into 10 raised to 5 into what is the L1 here? 150. 150 divided by A1 is how much? A1 is pi by 4 into what is dia? 30 square plus, now what is this? L2 is 100. 100 divided by diameter is 20, pi by 4 into 20 square.